Assalamualaikum. We are from Group 6, Section 2 for Civil Engineering Statistics. So today we're going to present about our group project with the title of Noise Level of Vehicles in Decibels Travelling Along Jalan University near UTHM. So here's my group member, Nur Aisha, Nur Fitri Alia, Fatin Nur Anisha, Fanik Farisha, and Nur Izzah Tahira. So now I'm going to cover about introduction. So this project focuses on analyzing traffic noise as part of a transportation-based case study. So our group investigated vehicle-generated noise level in decibels along Jalan University near UTHM using a smartphone app called Decibel DB Sound Meter to collect real-time data. So traffic noise, especially from heavy vehicles like buses, can reach up to 120 decibels and pose health risks such as hearing damage with a prolonged exposure. So we analyzed that heavy vehicles would produce the highest noise levels and tested this using various statistical tools, including descriptive analysis, measures of a central tendency, hypothesis testing, and ANOVA. The study aims to understand noise patterns and their implications in civil engineering, with the report covering data collection, analysis, and key findings relevant to urban planning and public.
Hi, my name is Nur Izzah and I will explain about methodology. So the first one is study area. The rural region near Jalan University was selected as the study location for this investigation. Various geographic and residential features were considered when selecting the locations. The entire research are measured around hundreds meters in length, and data on noise level was gathered using a sound meter. Data is collected in a real-world environment since the uncontrolled traffic technique does not impede traffic flow. Noise level were tested at one location along the line that was almost perpendicular to the main path. Next is descriptive statistics. These chapters include research study data on Jalan University traffic noise for 4 different vehicle types. The first one is cars, second one is motorbikes, then buses and lorry. This type of data can be objectively quantified, counted, or displayed as continuous or discrete data based on the information collected. As a result, we use descriptive statistics to organize, characterize, and summarize them. Categorizing, presenting, and characterizing quantitative data is the process of descriptive statistics. Techniques to summarize data, we choose three, which is central tendency and variability. Second one is depicts data, which is graph, and last one is organized data, which is frequency table. So for hypothesis testing, a statistical hypothesis is an assumption about a population parameter. This assumption may or may not be correct. Hypothesis testing is the term used to describe the formal procedure statisticians use to accept or reject statistical hypotheses. Using sample data and probability theory, a technique known as hypothesis testing is also employed to determine whether a hypothesis is a true statement. A hypothesis can be tested in two ways, which is the critical value approach and the probability value approach. Last is the analysis of variance. The statistical analysis method known as ANOVA separates systematic element from random factor in order to explain the apparent overall variability in a collection of data. The common factors have a statistical impact on the provided dataset, whereas the random component have no effects. ANOVA is a statistical test that determines if the means of multiple groups are equal, extending the t-test to more than two groups. ANOVA may be used to compare tests three or more means, which is group or variable, for statistical significance. It is also a parametric test. Parametric tests are statistical processes that are predicted on assumption about population distribution. To determine whether it is only a random error, the differences between the models are examine the effects of systematic intervention cause of one mean to deviate from another. This may be done by calculating the F ratio.
Assalamualaikum and selamat sejahtera. My name is Nur Shamidi Zulkarnain and my meter number is AF230024. So I will start by explaining the noise level distribution for four different type of vehicles that we recorded at Jalan University near UTHM. Based on our box plot analysis, cars showed that noise level between 78 and 91 decibels, and the data was quite stable, and there were no outliers. For motorcycles, most values range between 63 and 79 decibels, but we noticed that significant outlier at 63 decibels that which could be due to quiet engine or maybe a recording anomaly. Lorries and buses, on the other hand, had much higher and more consistent noise levels. Lorries range between 88 to 95 decibels, and buses from 87 to 94 decibels. Overall, that the box plot clearly shows that heavy vehicles produce much higher and steadier noise levels, while motorcycles are more variable. Next, we applied that ANOVA testing to compare the mean of noise levels across the four vehicles types, which are cars, motorcycles, lorries, and buses. The result showed a calculated F value of 113.58, which is much greater than the critical F value of 2.699 at the 5% significance level. This means that we reject the null hypothesis and conclude that not all the vehicle types produce the same average noise level. When looking at the mean values, we found that the motorcycle had the lowest average at 74.03 decibels, followed by cars at 84.33 decibels, and both lorries and buses had averaged above 89 decibels. This finding supports that the idea that vehicle type has strong influence there on environmental noise level. Next, for deeper analysis, we will form a hypothesis test to compare between lorries and cars specifically. Our null hypothesis stated that the mean noise level for lorries is less than or equal to the cars, but while the alternative hypothesis claimed it is greater. We used the z-test formula because both sample size were large enough and the population standard deviations were unknown. With a z-score of 7.58, which is well above the critical value of 2.58, we again reject the null hypothesis. This is confirmed that the lorries are significantly louder than cars on average. Supporting studies also shows that heavy vehicles contribute more to noise pollution than lighter vehicles.
Assalamualaikum. My name is Fatina Sharhaizan and my matrix number is AF230045. So now I will talk about the discussion. The data type that we got is quantitative continuous data. The variable that we measured is vehicle noise level. For the measurement characteristic, it was continuous numerical values across the wide range, which is the measure on a ratio scale is equal intervals through 0 points, and also it allows for meaningful comparison. For the statistical applicability, it is suitable for measure of central tendency of dispersion and also enables hypothesis testing and ANOVA. For the relevance, it supports valid, meaningful statistical analysis, and it also ensures accurate interpretation and informed engineering conclusion. So now I will talk about the real world problem, which is urban noise pollution caused by the increasing road traffic. And the location that we took is the residential and universities areas, including around University Tun Hussein on. The causes is because of the rising vehicle densities in Malaysian cities. So the effect, which is the higher emission noise level, often exceeding safe thresholds set by the World Health Organization, which is WHO. And for the health risk, it can prolong exposure to traffic noise above 70 decibels. It can cause stresses, disturbing sleep, reduce concentration, long-term hearing damage. And the critical impact is especially affects educational institutions like UTHM, where a quiet environment is crucial for learning and mental well-being. So now I will talk about the urban planners and civil engineers that can incorporate noise barriers. We can use acoustic walls and also the vegetation belts along major roadways to block and absorb sound waves. And we can use of low noise pavement materials such as rubberized alpha to reduce tire road noises. And we can also enforce strict vehicle noise emission standard and promote adoption of quieter vehicle technologies such as electric vehicles and also hybrid vehicles. Next is the implement traffic management strategies, which is reroute heavy vehicles away from sensitive areas such as school, hospitals, and also residential zones, especially for during peak hours. And lastly, the benefit of this solution. It can enhance public health and comfort, support sustainability urban development, and also promote a quieter and also more livable environment. We need to think beyond conventional noise mitigation methods and adopt an integrated forward-thinking engineering approach. Next, noise barriers and improved road surfaces provide immediate relief but only address symptoms, not the root causes. We need to promote smart transportation, planning by integration intelligent traffic system (ITS) to optimize vehicle flow, reduce congestion, and lower noise levels. Urban designers should implement zoning integration to strategically place educational and residential areas away from major roads. Next, invest in green infrastructure such as urban forests and green buffers, which absorb sounds and enhance the environment. Furthermore, we need to develop policies that incentive to use the electric public transportation and cycling infrastructure to reduce reliance on noisy vehicles. Next, we need to conduct educational campaigns to raise public awareness about vehicle maintenance and responsible driving habit, as poorly maintained vehicles generate excessive noise. Last but not least, encourage multidisciplinary collaboration among engineers, urban planners, policymakers, and also the public. Lastly, we need to focus on solutions that are technically effective, economically viable, and also socially sustainable.
Hi, Assalamualaikum. I'm Nifitri Alia Shari. I'm going to present about the conclusion part. So, for this project, we can conclude that traffic noise comes from many things like vehicles, engines, number of vehicles, road types, and how people drive. For example, higher the number of vehicles, higher the noise level. So, from this project, we conclude that big truck, which is low risk, give the loudest noise that reach 95 dB. Quieter vehicles can help more people than just building sound barrier because it's often cheaper, which is the cost is lower than we build the sound barrier. The last one, quiet roads and less tire noise will help UTHM more peaceful. That's all.